Hello, this is a short video presentation that may not be too short on compound inequalities. Compound inequalities. They're inequalities joined by the word and or. This is our second of 3 videos on inequalities. What the word and means, we're going to start with and. And means both conditions. What I mean by conditions is we're going to get 2 inequalities. Both conditions must be met. We're going to have 2 inequalities and they both have to be true. Absolutely both have to be true. All right? And the word or we'll talk about after we do a couple of examples. All right, let's do our first example. All right, here's our first compound inequality. We have 2 inequalities joined by the word and. I have to find the numbers to make this side true and at the same time make this side true. Any number that I graph has to work in both inequalities. So, basically, I'm going to do 2 separate things. I'm going to find out what makes the left side work, find out what makes the right side work, and then I'm going to find out which numbers are in common. So, I always like to have, regardless of anything with inequalities, I like to have my variable on the left side. So minus 5x, minus 5x. I get negative x plus 5 less than 4. And now I'm going to subtract 5. And I get negative x is less than negative 1. Lastly, for this side, I have to divide both sides by negative 1 because, I don't know what this, I'll make this a big negative, because I want to know what x is, not negative x. And because I divided by a negative, remember from yesterday, switch the direction. And I end up with x is greater than 1. Awesome. Now I'm going to do this side. Again, I want my x on the left. I'm going to show you what happens if you do it the other way. I'm going to put my x on the right. Minus 5x minus 5x. And to save time, plus 10 plus 10. Here, my x's cancel. Here, my 10's cancel. And I'm left with 20 greater than or equal to 2x. Divide by 2, divide by 2. And I end up with 10 smaller than or equal to x. Now here is something you need to do. This point right here, that little point, is pointing at the x. So when I rewrite this x and 10, because I want the x on the left, the point is at the x. Boom, boom, boom. All right. Now I want to graph this. But before that, I need to join this with the word and. You are going to be asked to solve and graph. So the solution here is x is greater than 1 and x is less than or equal to 10. We have another way that we can write this. I can also put x in the middle, and since x is larger than 1, I have the point is at 1, the point is at 1, the point is at x, 10. This means x is between 1 and 10. Normally, this is how I'm going to give the answers, but it means the same as this. And the format here is x, the little number, and the big number, with the symbol pointing the same way. All right, let's do one more example with and I'm going to give you the example just like we saw in that format. What you want to do, I didn't graph it, I'm so sorry. It's like really critical. Here's my number line. I always like to see the number 0, 1, and 10. This says, I'm going to look at this part here, x has to be bigger than 1. Bigger than 1 means from 1, just over 1, to infinity. On and on forever. But I can't be bigger than 10. The biggest I can be is 10. This says x has to be less than 10 or equal to 10. So I put in a filled in circle on 10, and I have to go this way. So x has to be between 1 and 10. Can't be equal to 1. Can it be equal to 10 but not bigger? So it looks like this. All right. Next case might look like this. If it looks like this, you want to write this inequality, -8 minus 5x less than 6 plus 2x. And you want to write this inequality. With the word and. 6 plus 2x less than or equal to 6 minus 4x. And then we do just what we did up here. Solve each of them and graph each of them. All right? And solve. I'm not going to do that. One example is enough. But you must, absolutely must, do this. You must break it up into two inequalities. All right, now let's look at or. Or means either is good. Either condition must be satisfied. Not both. As long as one of them is satisfied, we're good. As long as one of them is satisfied. So let's look at an example. All right, hopefully this will go quick. Video is already starting to get a tad long. All right, or I'm going to do it the same way. I'm going to solve both. So minus x, minus 2, minus 2, and I get 3x, these cancel, greater than, these cancel, 0. Divide by 3, x is greater than 0. Sounds good? Apparently this is going to be a little too big for me. And now here, I'm going to add 4n. I'm going to add 4n. I'm going to add 3. I'm going to add 3. And I get, these cancel, negative 3n greater than, these cancel, positive 6. Divide by negative 3. Divide by negative 3. Because I divided by a negative, this direction changes. Cancel that. I get n less than 2. Up, negative 3, my bad. So it's negative 2. All right, now we graph. Well, now we write our answer. Joined by the word or, x greater than 0, or x less than negative 2. Yeah, kind of a stupid thing I did. This should be an x, 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 and x. So sorry. This is my answer. There is no other way to write it. No other way to write. Can't join it like we talked about here. Can't do that with or. All right, now let's graph. We have 0, and we have negative 2, positive 1. Let's kind of orient ourselves. And x is bigger than 0. Use a different color. Bigger than 0. We go to the right. Or x is smaller than negative 2. All of these numbers, 1, it's bigger than 0. I don't care about this side. Negative 5. It's smaller than negative 2. Don't care about this side. As long as one of the conditions is met, I'm good to go. All right? And an or. We'll do this for a couple of days, and then we'll have one last topic before the end. All right. Have a great day. Hope the weekend is great. And I'll see you guys soon. Love you. Ciao. Bye.